In this video, I'm going over Azure Traffic Manager. Azure Traffic Manager is a global DNS service hosted in Azure. It extends functionality of DNS beyond simple name IP resolution, adding load balancing and advanced features such as geo-fencing, weighted priority, performance, and source IP-based name resolution. Before I go any further into that though, I just want to take a minute to remind you, please subscribe and like. That lets me know that this content is worth creating, and I'll keep creating it. Thank you. Just as important to what it is what it is not. It is not an IP-based global load balancer. It does not handle IP session data, BGP, or any other routing protocols. It is only an external DNS solution. At a high level, Traffic Manager works like this. The client looks up a resource with a custom, fully qualified domain name. That fully qualified domain name has a CNAME entry in DNS that points to the Traffic Manager profile. The client is then redirected to that Traffic Manager profile. Traffic Manager monitors the state of each endpoint. The endpoint IP is returned based on the routing method and endpoint availability. In this case, the routing method describes the way Traffic Manager directs DNS requests, not to be confused with IP routing protocols. Unlike other Azure services, Traffic Manager is global and not bound to any specific region. This makes it a great part of any high availability solution for externally hosted services. The services can be in multiple Azure regions, on-premises, or even in other cloud service providers. Traffic Manager will direct the client to the best endpoint based on availability and the routing method specified. Traffic Manager uses routing methods to determine the response to client requests. Routing methods can be any one of the following. Priority, where the highest priority available endpoint is returned. Weighted, this distributes traffic between the endpoints on a weighted priority, such as a 2-to-1. Performance, clients are directed to the endpoint with the lowest latency. And one thing to note, this is the lowest latency based on the DNS server doing the recursive query, not the actual client itself. Geographic, directs endpoints based on the geographic location. This doesn't necessarily mean that it's going to be the fastest response, but it is the one within the geographic region specified. Multi-value, this is kind of interesting. It actually returns the addresses of all healthy endpoints. And then subnet, this maps clients to a specific endpoint based on the source IP. All right, with that, let's move on to demos. Just a quick overview of what I've got cooking here for this demo. I have a client in West US and I've got a client in Central US. I also have web app service in West US and Central US. I'm using Traffic Manager to direct traffic at one of the two web apps depending on what client I'm coming from. The first test I'm going to run is with priority. So with that, let's get it set up. Here I am in Traffic Manager profiles. I'm going to add a Traffic Manager. You can also add it by clicking the green plus button and searching for Traffic Manager profiles. So I'm going to create one. Let's call this one CIR test. Now this name has to be globally unique, and it's going to have the fully qualified domain name of cirtest.trafficmanager.net. I'm going to leave it as performance, set my subscription. I'm going to create a new resource group. We'll call this one CR test RG. And it is going to ask for a location for the resource group. Just to be clear, this is not the location for Traffic Manager. Traffic Manager is global. This is only the location for the resource group. So I'm going to create. That's going to create the Traffic Manager profile. And here we are. Let's hit refresh. We'll give it a minute to create. Now I want to go in and we'll go into CR test. And you can see the DNS name for this Traffic Manager profile is cirtest.trafficmanager.net. If I hop over to my domain name registration, you can see that I have a CNAME for webtest.seraltos.com pointing to cirtest.traffic, fully qualified domain name, but it's just going to redirect to this Traffic Manager. That needs to be set up in your DNS registration. So let's go back to dashboard, and I'm going to create a couple endpoints. So I'm going to simply hit add. It is an Azure endpoint. I can also use external endpoints if the endpoint is not in Azure, so this could be on premises or at some other cloud provider. But in this case I am, so I am in Azure, so I'm going to leave it at Azure endpoint. We'll call this West Test. It's an app service, so I'm going to select that from the list. And then here's my West app service, and then I'm going to click OK. Now, while that's getting set up, I'm going to go and create a second one. Still an Azure endpoint. We'll call this one Central Test. And again, that's an app service. And we'll select that and click OK. Here you can see it's checking the endpoints, so I'm going to give it a second to check, and they should show online in just a minute. Here we are. They're coming up as online, which means they are both available. The first thing I'm going to do is come over to my machine or my browser. This machine is in the central US. If I go to the web page webtest.seraltos.com, you can see it is going to the central web app, which is what I expected. Let me hop over to another machine that's in West. And here you can see it's the West app service. So this shows that machines in central US are getting directed to the central US web service, where machines in West US are getting directed to the West app service. Now if we come back, I've got a directory set up on both of these called test with a test.html. So you can see it's pulling up a central web page test file. That's a simple file just to use for testing. So the reason I did this is it might be to an advantage not to probe the default website. By going to a subdirectory, you can remove that from your statistics, or you can also do custom page that returns maybe some codes you want to keep track of. But at any rate, there may be reasons why you want it going to a subdirectory. Another reason could be ADFS. It will not respond to the default page of like adfs.domain.com. You have to actually tell it a subdomain. There's also SSL enabled on that. It won't respond to a straight HTTP request. It'll only do SSL. And you have to pass through the domain name. In this case, it's going to each of these endpoints individually, not using the host name of WebTest. So let's go into configuration and make some changes. So I'm going to first change this to priority, and I'm going to leave the DNS time to live as it is. I'm also going to leave the protocol to HTTP, although you can modify that if need be. I don't have a certificate on these app servers, so I'm going to leave it as it is. I'm going to put in a path. We'll call this test and test.html. Now if you have a custom header or host name you want to add in, do that by simply doing host, colon, and then the host name. So now I'm just modifying what the probe is actually probing on those endpoints. And you can set a status code if you want something different than the 200. And then there's also the endpoint failover settings. I'm going to leave those as they are, but if you need to change those, you can do that here. So I'll hit save and go back to endpoints. Now I have the Azure endpoints, but there's a priority on them. So West has a priority of 1. Also note that if I go into either one of these, I can change the priority. I can also add a custom header to that endpoint instead of doing it globally. Now if I go to Central, do a refresh, now you can see the Central client is going to the West app service. And that's because that has a priority of 1. So it doesn't matter what the performance is, it's always going to go to the highest priority website. But what happens if that's down? If I go into that app service, we'll go into the West web app, and I'll go down to App Service Editor, hit go. And this is going to open up a preview editor that I can use. All I'm going to do is go in here and delete that directory. So I'm deleting the test directory off from the West web app. Now if we go back into Traffic Manager, and if we give it, I think it's going to take about a minute, minute and a half, we should see that the West test is going to go to the status of degraded. Keep in mind that if you're testing this on a machine, you may have to do an ipconfig/flush DNS just to get things to clear out of the machine. Pages could also get cached, so you might have to close Explorer or your browser and open it back up. Okay, so this endpoint is showing as degraded. If I go back here and we're gonna go to webtest.seraltos.com. So one thing that you notice right away is it is connecting and it's still going to West app service. And that is because it's cached in this browser. If I go to IE or another browser though, here you can see it's going to the central, which is what we expect because the primary is down. So this is on central, going to central. But central is a second priority, but it's not sending the request to West because that's degraded. And this is still going to West because it's cached in the browser. So that's how you set up an Azure Traffic Manager profile along with Azure endpoints. You can also modify the probe URL in the configuration tab. You can change the host name as well as the protocol. One last thing before I go, there's a right and a wrong way to configure internal DNS. So I'm going to go over the right way first. Here we have West client. It's going to reach out to its local DNS server in West. That DNS server is going to do a recursive query, which is going to land it on Traffic Manager. Traffic Manager is going to see the DNS request coming from a server in West. It's going to hand back the IP address of the West website. That's going to get handed back to the client, and the client's going to go to West Web. So that's the way it should work. Now, occasionally, companies will set up internal DNS to forward all DNS queries into like one site or one location. And maybe there's large DNS servers that do caching and all sorts of magical stuff, or they're the only servers that are allowed outbound DNS requests. So what happens in that environment is the same West client goes out to its local DNS server. That DNS server, instead of doing a recursive lookup, it actually forwards that request to another DNS server. Alternatively, that client could just be set to use this DNS server in the central region. In any case, the DNS server in central is going to do the recursive query. It's going to take it to Traffic Manager. Traffic Manager is going to see that the query is coming from central, so it's going to pass back the IP address for the central website. That's going to go back to the client, and the client's going to connect to central. In this environment, because Traffic Manager sees a query coming from a DNS server in central, it's going to pass back the central IP address. So this client is not going to use the closest or best performing web server because of how internal DNS is set up. This is not an issue specific to Traffic Manager. Any sites that use content delivery networks like YouTube, Netflix, Office 365, they're all using the same technology to see where that DNS query is coming from and try to get the client to the closest endpoint. By forwarding DNS queries to another region or another site, another state, another location, it's not going to get the client to the closest endpoint. So with that, please, if you like these videos, subscribe, and thanks for watching.